So you have 2 times the square root of 13x, all of that squared. What does that mean? You're going to write it twice there. Does that get in the board?
Yes.
Yeah, it's just the board though. It's like the upper board.
Yeah,
There you go.
That was in the middle.
The whole board.
It's in the middle.
It's fine.
It's
Okay. All right, so really that's what you need to do is rewrite it. And you're multiplying.
Push it down. Keep going.
No.
I'm going to leave it alone.
So it's like covering the 13x.
Oops, no. I'll have to glare.
Yeah, sorry, that might be the glare. Okay, what's 2 times 2? 4. What's the square root of 13x times the square root of 13x? Square root of, okay, someone said it, but 169x squared. Can you simplify that? Can you break this down? Here's a hint. I'm trying to give you some hints.
13.
Yeah, 13 and 13 gave me that, so 13 and 13.
Wait, I'm confused. How do you do the inner?
Oh, is this a binomial? Like, does it have 2 terms? It's only 1, and that's only 1, so you don't do FOIL. Okay, I take out a 13. What does it do with that 4? It multiplies it. What's 13 times 4? 52. And then what about this x squared? What happens to that? It's a group, so it comes out as x. What was left behind in the square root?
169. Nothing.
Remember, 169 broke down into 13 and 13, so we took that out. Nothing's left. It's 52x. That's as simple as it gets. Okay. How many of you were pretty much able to do it on your own? Like, maybe you need a little bit of guidance. Okay. Do number 4. Number 4 is not the same problem. Number 4 has 2 binomials.
Wait, no, Mr.
That's okay. So I have the square root of 5 plus the square root of 2 times 3 times the square root of 5 plus 4.
When you're doing this, do you do, like, for example, do the 3 square root of 5, are they together? Can you help? Okay.
Yeah, and the reason I know that they're together is because the only thing that separates things are plus and minus signs. So that's together, that's together. Those are the 4 terms. All right, you do FOIL because you have 2 binomials. And I'm going to start asking some people about what they get with FOIL. Give you a little bit of time. Yes, ma'am? Are you sure? No, I'll come to you. Yes, ma'am. Which one? These 2?
Yeah.
It'd be 3 times the square root of 25. All right, Chelsea, what do you get when you multiply the first terms? 3 times the square root of 25. I'm not going to simplify yet. Outer terms, Jack.
Well, I haven't actually done it yet. So,
What's the square root of 5 times 4 times the square root of 2?
I don't know.
You do, what's 1 times 4?
4.
And then square root of 5 times square root of 2?
I know what 5 times 2. It's 10.
Awesome. Callie, what are the inner terms multiplied together? Yep, these 2. What do I do what do I get when I multiply them?
3.
Yes, 3 times the square root of 10. And Elizabeth, what are the last terms multiplied together going to get me?
4 times square root.
Good. And again, you could simplify, but that's like the raw answer so far. What does this become right here? What is 3 times the square root of 25?
15.
Yeah, because it's really 3 times 5, which is 15. This one stayed the same. That one stayed the same because there's nothing to simplify. But what about the last term? Yeah, because it's really 4 times 2, which is just 8. All right, what are the like terms? Yes, ma'am?
You could do 15 and 8.
Which is
You
23?
could do the 4, yeah.
Anything else to simplify? No, how many of you got that one? Okay, good. Hi. Okay, we're moving on to division. Did you guys have a good lunch?
No.
Did you get enough to drink? Okay, good.
Why is it not 6? Wait, is it? Wait, never mind.
4,
I
yeah.
thought, yeah, I see.
Okay, let me give you a property. This is super important for this part of the lesson. It's called the quotient property of square roots. Quotient property of square, I'll put it right here, roots. It was funny because toward the end of the last class period with the other 8th graders, someone says, we're just making this stuff up now. I'm like, nope. These things are things you've looked at already. It's just with more complicated numbers. And then someone dared to say this. Math came up by sinful men, so math must be wrong at times. It's possible. I get wrong answers because my mind is not perfect, right? There are things I mess up on because I'm not perfect. That's because of the fall. But have you ever heard of discovering something? Do you know what it means to discover mean? Discover. To uncover what was already
There.
there. So like if I come in here one day and I see on the ground a nice, beautiful looking red pen. I mean the red pens that just flow as you write on the paper.
Mr. A's
I pick it up and I say, look, I came up with a pen. I discovered a pen. It was there, I picked it up, but it was already there. What we're going to be dealing with this stuff is not something, you know what? Some smart dudes in some times past, you know what? I like quotient. Yeah, you like quotients too? Yeah, I like square roots. Let's put them together. This is there. We uncovered it. So what is it? It's pretty basic. If I had the square root of A over B. Okay, so if I have a square root basically of a fraction, is what I'm saying. The square root of a fraction. Whoa. Why did we call this quotient? Do you guys know what a quotient refers to? Division, right? Dividing. There's no dividing there.
Oh, but there is.
A fraction is always a division problem. You can always see it as a division problem and it'd be fine. Okay, so that's why we call it quotient property. This is what you have. If you have the square root of a fraction, you can break it into 2 parts. The square root of the numerator over the square root of the denominator. Like, okay, why would you want to do that? Well, we're going to see why we want to do that. Does anyone know maybe why you might want to do that?
Make it easier to look at.
Okay, make it easier to look at, to work with. Okay, I don't know how to factor a lot of fractions because I'm like, what fraction goes in this fraction? But then if I break it down into 2 parts, I can figure out what does the numerator break down into, what does the denominator break down into. That's one example, but there are others. So let me give you this problem right here. All right, ready? The square root of 75 ninths. Can you simplify 75 ninths into something useful? Like, can you divide 75 by 9 and get something that maybe is easier to factor? No. But I can use a quotient property. And what I do is I break it down into its parts. That didn't help. It just gave me 2 square roots instead of 1. Oh. Isn't that nice? Yeah. Yes, sir.
Why don't you just break that down into 25 over 3, or the square root of 25 over 3?
You're getting there.
Yeah, can't you just simplify it?
You can. Yeah, we're going to look at both ways of doing it. Yes, good thoughts, guys. But anyway, what is the square root of 9? 3. And then the square root of 75, I didn't do anything with it.
Oh,
Right, I didn't do anything yet. But what can you do with the square root of 75? You could break it apart, right? And
It's division, can I actually do the division? 75 because 3 is 75.
okay, can I finish this up and then we'll go back to your questions because I think some of you have good questions, but let me finish this right here. How can I factor that out? So 75, what do you do? 25 and, oh yes, 3, sorry, I was going to say 5. All right, and then that's done. You get 5 and 5. All right, so what would have come out?
25 square root.
Okay,
Yeah.
sorry. 5 times the square root of 3 is what you're left with, right? You take out a 5, so I'm left with 5 times the square root of 3. What's in the denominator? 3. Can I simplify any more? What do you think? Can I make it any simpler? No. All right, I'm going to give you a definition of simplified first. Okay. Whether you're dealing with 9-1, 9-2, 3, 4, or 5, the way you know a number is simplified is if this is true. Is there any perfect square inside the radical? Is there any other perfect square inside that radical? No. So that part is simplified. Is there any fraction inside the radical? Is there any fraction inside the radical? No. That part is simplified. So 2 parts so far good. And then the last part, which we're really going to hit on today, this afternoon, is there a radical in the denominator? Is there any radical in the denominator? No. That's a good sign. So you have 3 things you're looking for in all these problems now, and it's true for all of them. Let's move on here. Oh, sorry. So with the fractional problem, I think a couple of you had it. I almost forgot. So 75 over 9, could you have simplified that a little bit? 3 goes into 3 goes into 3 goes in that, 25, and then you get 3. But then you're going to get stuck because you don't know what the square root of 3 is, right? So you kind of get stuck. There is a way to get out of that, which we're going to go through later on in this lesson. So I want to keep it easy with that. And there is a way to escape that problem, but not yet. Okay, let's look at this one. Square root of 28mn over 8n. Okay, the book works this out a little bit different than what I'm going to do because the book really likes perfect squares. And it's good. If you can identify perfect squares, I hope you can find those out. But if you can't, you're kind of stuck. Okay, looking at this right here, can I simplify anything in that fraction? Okay, what can you simplify? Just look at the fraction. It is a fraction, so you can cancel things out. Okay, so I think I heard n and n. They cancel out completely. And then what goes into 28 and 8? 4. 4 goes into that 7 times. 4 goes into that 2 times, right? I'm just going to rewrite it. 7m over 2. Is that correct? That's simplifying that fraction. Okay. Is this a simplified radical?
Yes.
Why not? There's maybe 1 or 2 reasons. There's a fraction inside the square root. You can't do that. Do you know how to break that apart?
You put it into its own.
Yep. The numerator gets its own radical, and the denominator gets its own radical. Yay, we got rid of that fraction inside the radical. But I have a square root in the denominator. That's a no-no, by the way. You know why it's a no-no? Why we're so picky on that? It's actually for your sake. It's harder. You know why it's harder to use? Okay, do you guys remember last chapter? I know it's been a while now. I'll get those tests back to you. Sorry. Swivel has me now recorded that I will get them back to you soon. When you're adding or subtracting fractions, what do you have to have? Good. Like denominators, common denominators. It's really hard to get a common denominator with a radical. What's the common denominator between 3 and the square root of 2? It's 3 times the square root of 2. That's going to be so messy with your fractions and adding them together. There's a way to eliminate that, okay? How do I get rid of this square root of 2? Ready? It's a cool process. There's a special number out there that we uncovered, we just made up.
1.
It's 1. Yay, the winner is 1. Remember, did I tell you guys that there's a cult that worship 1? Okay. This is one of the reasons why they would do that. Even though don't do that.
One reason is nice.
Oh, yes, that's what I meant. All right. I'm going to multiply this by 1. Okay?
It's the same thing.
Awesome. What property is that?
Property of
Identity. Identity
Right,
property.
if you multiply by 1, is it going to get rid of the square root of the square root of 2?
Sorry, I got 3 things there. Yes, and what?
Is it going to get rid of the square root if you multiply by 1?
By 1, yes.
It
Yes,
said
okay.
1.
Yeah, you're like, wait, Mr. A, you said 1. What's wrong with you? What is the square root of 2 over the square root of 2? It is 1. So I multiply this fraction by 1. I don't change its identity. And here's a quick math problem you could do. What's the square root of 2 times the square root of 2? Go.
1.
Sorry. What's the square root of 2 times the square root of 2?
Square root of 2.
I heard 2 answers and 3 wrong answers. 2 correct answers, 3 wrong answers. Let's try that again. What's the square root of 2 times the square root of 2?
2. 4. Square root of 4.
Which is?
Oh, because it's a pair.
4.
2. Oh, that's a pair.
That's what I was thinking, and you're like, maybe he's wrong. And I was like, I'm probably wrong.
Whoa, let's rewind that.
Rewind.
Okay,
Oh, wait,
and then
3 of us are
no. I don't. I'm not saying maybe the tone that you used was a little rough. Okay. Anyway, is the square root of 2 times the square root of 2 the square root of 4?
Yes.
And what is the square root of 4?
2.
Okay, here's something you need to get down. You need to start getting this down. A square root of a number times the square root of its same number is just that number. So just leave it like that. All right, but what's left up top? Review of
14m.
square root of 14m. Okay, do you have a radical in the denominator anymore?
No.
No. Do you have a fraction in the radical?
Yes. No.
No. Do you have any more perfect squares in the radical?
No.
No. Simplify.
There it is.
All right, let's go with another one here. 12 times the square root of 18. 3 times the square root of 2. Is that simplified? No, because what's in the denominator? A radical, a square root. Don't want that. Many ways you can look at this. I want to hear your input. What do you think? Yeah, give me something. Sophie?
Well, since it's divisible, 3 is a factor as well, so can you cancel out?
So are you canceling these 2 out? Yes, you can.
You could do 4. And then, wouldn't you?
Okay, hold on. Let me rewrite that now with what you just said.
And then since there's a radical in the bottom,
A radical.
yeah, that, wouldn't you be able to just multiply
By 1?
the square root of 2, which is 1? Right?
Yes.
2 over 2, yeah.
Square root of 2 over the square root of 2, yeah, which is 1. That's what I want.
Would it still be 4?
Yes. Yes, you could.
18.
Yes.
36.
You could. You don't have to. If you do before or after, you get the same answer. If I read you correctly. Let's see.
You have to do less work.
Choose about
No, because you're going to have to simplify before or after. So you still do it sometime. All right, anyway. What's square root of 2 times square root of 2? Go. 2. It's just 2. And then what do you get up here? 4 times the square root of 36. Ugh.
6 times 6.
Wait, couldn't you still cancel
Oh, wait, it's
out?
over 2.
Wait, Mr. Ray, couldn't you still cancel out and then just be 4? And then you could say the square root of 36
Okay,
and then you...
this is where you guys can start doing your own thing, and you can do it in any order here. Okay, can you cancel out the 4 and the 2?
Yes.
Yeah, okay, so if you want to do that, you can do that. So now you have a 1 denominator, even better. And then what is the square root of 36?
6.
So what's 2 times 6?
Jesus.
Is that simplified?
Yes.
Wow, okay. Any questions on that?
It goes so quick.
Sorry? No, I would not want to do that to you.
Yes, you would.
3 times the square root of 2x over the square root of 11x. Oh, sorry, 11y. And that does make a big difference. All right, listen to me, guys. This is not simplified. Do you agree with me?
Yes.
Why?
Because
Why?
You said it.
it's
Why?
You're a teacher.
Why? What do you think? What's wrong with it?
It
Everything.
doesn't look simplified.
It doesn't look, but how do I know?
There's a figure in the bottom.
The denominator has a
Radical.
a radical. Good. Square root. Yep. You can't have that. Yes.
Does the variable matter?
Mhm.
Yes.
Like it does have an impact on the number. Yeah. Okay, listen up, guys. I want to get rid of that square root in the bottom. So what do you multiply? Trick question. What do you multiply that fraction by?
Over.
Y over the square root of 11y. Okay. Square root of 11y over the square root of 11y. Okay. What's the square root of 11y times the square root of 11y? 11y.
22.
All right, that's what I got in the bottom. I rationalized it. Okay, what do you get up top, though? This is weird. This is what we did this morning. What do you get up here? 3 times the square root of...
22 x y.
Yes, ma'am, go ahead.
Okay, so I can't hear what we're doing. Why did they get 121y squared? Because they just multiplied the two square roots on the bottom. But
Yeah, so what they're doing is they're doing this. They're doing this times this technically is 121y squared, isn't it? But what is the square root of 121y squared? It's 11y. So, I don't know.
Why did you take?
Because I'm wanting you guys to start getting it automatically. Just know, okay, ready? Here's a question. It's a verbal one. Ready? What's the square root of 17 times the square root of 17?
2.
17. It would be 289. Square root of 289. You're like, okay. Which would equal 17.
Why did you take the square root cut away from the 11?
Yeah, because,
There, and then you just stole it.
ready?
Yes.
I'm going to give it to you again. Because of this. Okay, ready? This is that, isn't it?
Yes.
Remember, we just did that this morning, or this afternoon. And what does a square root and a square do? Wait, someone say it. Did I leave you there? They cancel each other out, so you're left with that. Okay, this process of getting rid of your square root in the denominator is called, and you need to write this down, rationalizing the denominator.
I have a question.
Yes,
Is
ma'am?
that all that you can do on that problem?
Yeah, because 22 doesn't have a perfect square. X and Y don't have perfect squares. 3 and 11 can't cancel. 3 and Y can't cancel. Y and Y, by the way, can these cancel out? Great question. Actually, thank you for bringing it up. Can 22 and 11 cancel out? No, because one's stuck inside the radical, one's outside. They don't cancel out. Okay, sorry. Rationalizing denominator. Real quick, guys. Who has a calculator?
I do.
Okay, I'm not going to deal with the variable just because it could be any number, but I want to look at the 11. Someone put the square root of 11. Tell me what it is. Raise your hand, please. Real quick. Okay, Cole.
3.31662470.
Okay, is that all? What do you think? Is that it? No, that goes on infinitely and it never repeats. That's called an irrational number. It never ends and never repeats. This is an irrational number. That's an irrational number. What happens when you multiply an irrational number by itself? You end up getting a rational number. I like rational numbers. And so do you. Yeah, we. So, yes. Us. Okay, so that's what we call rationalizing the denominator. All right, let's take it back. Turn it back a little bit.
Do you say me and
Bella.
No,
Bella
you
and
lost
I.
it. You
I'm gonna teach you this.
All right.
Either Bella and I are gone.
Shh. Okay, let's rationalize this denominator, please. I have a denominator of the square root of 8. I don't want the square root of 8. How do I get rid of that square root of 8? Multiply by. Sorry, yeah, the square root of 8 over the square root of 8, which is really just a big fat
8.
1. This is 1, right? That's the identity property in action. But what's the square root of 8 times square root of 8? 8. What's 15 times 8?
120.
Good. So I get the square root of 120 up here, right? Yay, I'm done. Yes, simplify it as much as you can. So 120.
20 times the square root of 30.
I'm gonna go.
2 times the square root of
There, you can go many paths here, and I'm doing the long way for those who are not, maybe not as quick on getting this. That's okay. The more you do this, the more you practice, the better you get at it. Just get quicker. What comes out? So I got a 2, a 2, a 2, a 3, and a 5. I get a pair of 2's coming out, which comes out as a 2. And then what's left?
30.
What's left behind?
30.
30. What was in the denominator?
8.
Yay, I'm done.
Woo!
No. Couldn't you simplify it more with the, so what did you just do the square root of 30 over 4?
Yes. That's okay. I'll help you zone back in. Awesome. Okay.
Straight and taller.
Go ahead and do number 6 on the try these. Number 6 real quick. And then I'll give you the last type of problem, which is the ultimate type of problem. Yeah, try these, number 6. Yeah, and you're good with time. You have more than they do. Number 6 on page 233. Chelsea, what do you multiply this fraction by?
The square root of 5 instead of the square root.
Which is also known as 1. I like 1. Jack, what's the square root of 5 times square root of 5? Great, 5. Mandy, what's the square root of 10b squared times 5? Square root of 5.
50b squared.
Say that again?
Square root of 50b squared.
50b squared. Great. Can you simplify that, Molly? What can come out of this? 5b times the square root of 2. Is that what you guys got? Great. Is that it? No. Finish it off.
Wait, oh, you can cancel.
Because they're being multiplied. Remember, they're just being multiplied. If they were being added, no, you can't just
I
do
thought
that.
5B was like a thing,
It is a thing.
but you have to. Okay.
What's going on between that thing?
They're being multiplied.
Awesome. If they were being added, they stay as a thing. If they're being multiplied, they'll be broken up. Yes.
Wait, Miss, why wouldn't it be divided the 50 and the 5, and then I got 10.
Oh, can you just divide these two together? No, one's under the square root and one's not. So don't divide them out. This is under a square root.
Yeah,
That is not. So you can't just divide it out.
so you factor the top.
Yep, factor the top, get it simplified. Then you can cancel a 5 and a 5. Okay, here's the last type problem. Oh, a lot of kickback on this. Not yet.
Not yet.
Wait, so number 7?
This is the last type. This is it. This is the final type of problem you're going to do.
Are we doing my
Yes.
girl?
I think it's that. Let me make sure. Okay, yes. All right. This puts it all together. This is not simplified for many reasons, right? You understand that. But the main reason it's not simplified is because I have what in the denominator? A radical. No radicals in the denominator. You can't have that. Okay, so what am I going to multiply by? You should be getting good at this. Square root of 3r times over the square root of 3r.
Are we never gonna have binomial on that?
Yeah, but not this year. Oh, I wish there was. Oh, man.
Mr. A's wish is only for us to have harder math practice. You can teach us.
No.
Do you
Trying to help
see the
you.
look on our faces when we make all the answers right?
Okay.
Here are some of the looks on your faces. Let me imitate some of them. That's some of your faces.
Now,
Max is always smiling.
make the face that Max does when you hand him back all of his homework this question.
Or 10.
Square root of 3r times square root of 3r.
7. I don't know. 3R.
3r, yay. Now look at the top, guys, and please, this is something from the past that didn't. You're multiplying the square root of 3r by the numerator, right? The numerator is it's a binomial, which means it is a.
You have to multiply both FOIL.
It has parentheses.
FOIL.
Not FOIL necessarily, but it's a group. It's a group. Yep, it's a group. Keep it together. So what am I going to multiply the square root of 3r? What property? Distributive. Please do the distributive property. Go. Have you done that already? Oh, wow. That's good.
6r squared.
Hold on. Let's go quiet here because I want to help you guys out. Ready? Okay, ready? Max. The square root of 3r times 6 times the square root of r. Okay, first, what's 6 times 1? 6. What's the square root of r times the square root of 3r? The square root of 3r squared. Good. That's the first term. And then, yes, plus, because these two are going to give me a plus. What's the square root of 3r times the r times the square root of 6? R times the square root of 18r. Very nice, 18r. Okay. It's not simplified. I hope you can see that.
6r. You can divide 3. No. You could.
Simplify these two. Simplify those two. Do that.
Oh, couldn't you do
Sorry, simplify those first. Just simplify this and simplify that. Please, just do that first. What comes out of the first radical?
R.
Yep, then r. So you get 6r times the square root of 3. That's the first term simplified. The second term simplified, r does not come out because there's only one. But what can come out of the 18? What's 18 factor? 2 times 3 times 3. So a 3 can come out. So you're left with 3r times the square root of 2r, right?
But how do you do the? So then can you cancel 3r? Oh wait.
Okay, hold on that. It's a good question. Are we okay up to this point?
We are.
Yes. That's awesome. All right, anyway. That's awesome. Okay. I got plenty of more of that. Okay.
Can
Go.
you cancel?
Are you sure?
Keep going. You're on a roll. Okay, sorry. Go ahead.
Can't you like simplify both of them? But like, which would you do?
All right, guys, listen to me very carefully. I'm going to do a little disclaimer. You do one of these problems, and I want you to try it. If you don't get it, it's okay. It's a hard concept, but some of you might be able to see it, and it's great. If you can't, you do your best. Okay, ready? You cannot just cancel those two out, and you cannot just cancel those two out. You can cancel them all out if you did something.
Multiply them by 3R.
You add it to.
Oh wait,
One
Mr. A, you can add the subtraction.
Good
You can
job.
add the
No, wait, no,
sir, you no.
Leave it alone. I'm not going into that. I'm sorry. I wanted to.
Are you sure about that?
Can't you do-
one thing on that?
If you
the
multiply
one thing on
by
the bottom,
one,
you just
three
do
R.
something, add them together. The less work, the
That's good, Cal. Yeah. You could do this as a fraction, that as a fraction, simplify, bring them back. Very nice, very nice. I'm not going to make you do that because I wanted to hear your feedback and I'm like, it's not there. Okay, okay. But not too hard. Homework is, so I'll accept that.
R, sure you want to give us homework, Mr. Allen?
You're milking it here. 2 times 2 to 20 even.
3 times 20 even.
I gotta get back to it. All right, once you get that written down and you're done talking, I will start working out the problems. Once you start talking again, I pause. And I wait until you're done talking before I can keep going. Okay, goodbye, Swivel.